Okay, thank you. I'm down on the programme as a Research Director for the UK Energy Research Centre, which is a multi-university collaboration that looks at the energy system as a whole. I should say, I have to say, there's news hot off the press is that I will cease to be Research Director of the UK Energy Research Centre after the end of June, and I'm going on to a new role which I'm contractually obliged to describe as the Research Council's UK Energy Programme Strategy Fellow, which is a horrendous mouthful that I can't shorten contractually. My role there initially will be to create a roadmap for the research councils of what research they should be putting in place following the recommendation by quite a critical international review panel. So that's what I'll be doing for the next 15 months or so after the end of June. I should also say that this is definitely not a full-time role. I'm also a member of the Committee on Climate Change, so I have to take responsibility for some of these ambitious targets and the 50% number that David presented in his first talk. Now, in all these different roles, I am obliged to be independent, evidence-based, and not an advocate. So I'm not a renewables versus nuclear person, to look at the evidence underlying them. And I have to say, since in my new role, I'm going to have to be collaborating a lot with the Science and Innovation Group in the Department of Energy and Climate Change. The title of my talk, which I didn't pick myself, why don't HMG get it, might cause me some difficulty. So let me reinterpret this slightly. It depends what the IT stands for. Robin, you may have meant why don't HMG get a proper understanding of what's really going on. You could also say, why don't HMG get the credit they deserve for a visionary energy policy well executed? I suspect the truth is somewhere in the middle of these moving forward. So let's keep that in mind. So what I thought I would do, without PowerPoint, in a very uncharacteristic way of academics, is to first of all go through the UK's overall renewables targets, and I will very much keep to renewables. I'd like to go through and give a few personal views on each of the major technologies and what the opportunities and some of the difficulties are. And then I'd like to finish up with a few general remarks about the suitable orientations for policy, and in particular the issue of electricity market reform, which David mentioned in his talk. So, just to remind yourself what the targets are, under the EU Renewable Energy Directive, we have a target to get 15% renewables into the UK energy system by 2020, and roughly this is going to imply about 30% of electricity by 2020 coming from renewables, maybe about 12% heat, and maybe 8 to 10% of transport fuels coming there, depending on sustainability issues. Now, the Committee on Climate Change looked at renewables prospects beyond 2020, almost exactly a year ago, and we actually took an indicative scenario of about 40% renewables by 2030, with much of the balance coming from nuclear. But you could envisage other kinds of scenarios as well, and there is no physical reason why you couldn't get up to 70% renewables on that kind of time scale if you were wanting to drive for it. It's the economics, the financial issues that will determine it. And something, again, to pick up on what David said, we've talked too much about electricity. The heat side of it, I think, is particularly important moving forward. And it's a much harder sector to get a grip of, because with electricity you're looking for big market players, very sophisticated, they trot through the porch of Whitehall Place on a very regular basis talking to government. With renewable heat, it's about moving millions of households and hundreds of thousands of small businesses, and that is a much, much bigger challenge than engaging, I think, with the big electricity companies. So again, the CCC, maybe 12% renewable heat by 2020, but looking out to 2030, could maybe about 35% of heat needs being met by renewables. And let's not forget that electric heat pumps fall within the definition of renewable heat, as they extract heat from either ambient air or from the ground, depending whether it's an air source or a ground source heat pump. So let me start on the journey through the various different renewables technologies and where we think we are. And the first one, I think, is to talk the dominant technology at the moment, which is onshore wind. It is a relatively mature technology. We've had it for a long time, but there's still the possibility of reducing costs as you get bigger and better at putting them up. And at the cheapest, The best sites where you have very good wind regimes may well be close to parity with natural gas generation at the very, very best of sites with a good wind regime. But overall, onshore wind will still need a subsidy if it's going to come onto the market. However, I should say we are increasingly moving to a system of taxing carbon, and all the calculations the UK Energy Research Centre has made, the carbon price floor that was introduced, if carried through at the kind of levels of ambition, would be enough to drive onshore wind in comparison with natural gas by the 2020s. It would look like a very good kind of proposition. I think the clear issue with onshore wind is the question of visual impact, getting turbines through the planning process. I was up in Scotland the weekend before last, and I took my 86-year-old mother for a drive through the Perthshire countryside. And as we came over the top of a hill, you could see a set of wind turbines over the next bridge. And we then started having a talk about how visually attractive or unattractive they were. And she said to me, well, I know some people complain, but when I look at them, I think of butterflies. I think they're beautiful. And there is a very big difference between those who look at them and see a lavatory brush and those who look at them and see Wordsworth's daffodils. And this is a cultural aesthetic issue. It's not about an objective fact. And this, different in almost the aesthetics of wind, I think is something that we will have to live with. I think the interesting issue is that those who have strongly opposed wind turbines on landscape grounds also try to adopt another set of issues to throw into the argument. Before I came here, I was just looking at the perspective of the National Opposition to Wind Farms initiative that's just been set up, which goes on to raise another set of issues about the backup costs for when the wind doesn't blow, or the alleged fact that wind turbines may not actually save carbon dioxide. And the particular paper they cite on that latter issue is so deeply flawed, I just can't start to go into it. So there's a lot of bogus, pseudo-objective arguments that are actually being put in place, I think, to bolster more subjective, aesthetic arguments about the position of onshore wind. It should be said, again, under the UK Energy Research Centre, we're carrying out quite a big project that's carried out by a guy called Nick Pigeon at Cardiff on public perceptions of energy system change. And there's a very clear message that the public in general are actually quite supportive of wind and renewable energy in comparison with the alternatives when they're presented what the options actually are overall. I think the big challenge for onshore wind is whether this kind of campaign against onshore wind and visual grounds goes beyond local initiatives and local campaigns until it joins up to become more like a movement. And that, I think, would be the biggest challenge, I think, for onshore wind going forward. I have to say, I had never heard until the election last week of the concept of wind turbine Toryism. I now have heard it, I understand, I think, what it is meant to be. Let's see how it plays out. Now, moving on to offshore wind. This is a much more challenging technology than onshore wind. It's much more expensive for the obvious reasons. You've got to go offshore to construct it. It's much more expensive to maintain because you need to get the boats out there, and you need to hook it up with transmission to get the power to shore. And offshore wind, interestingly, has shown a characteristic of lots of new technologies when they're in their early stages. The costs have actually gone up rather than go down. And if you look back to lots of energy technologies, they generally follow this pattern. In the initial period, there's technology exuberance and optimism, and the costs are actually higher than people anticipate. But as you start putting it into practice, deploying the technology, the costs start to come down again in quite a significant way. And again in Newkirk, we did really quite a detailed study of why offshore wind costs had increased. And it was a complex mix of reasons. It was movements in the exchange rate, it was underlying commodity prices, and what we delicately call market congestion, which is the ability of suppliers to charge more than it costs in the marketplace because of limited supply. And all of these reasons explain why offshore wind costs go up. But we can clearly see the prospect that they could come down maybe 25–30% by the early to mid-2020s. And we're being told by people in the industry we're being far too pessimistic, when we say it's 25–30%. So I think cost decreases are potentially there. I think the other thing I would say about offshore wind, This is really where the industrial opportunities arise in the UK. There are a number of companies very, very interested in inward investment for manufacturing turbines, and there are clearly prospects for further European or global markets in offshore wind. And this is one particular area where I'd strongly emphasise, I think, the industrial opportunities that arise from the technology. I have a colleague at Imperial College, Goran Strabak, who does a lot of modelling of European electricity systems, and his modelling clearly shows that if the Germans want lots of renewable energy, which they do at the moment, one of the cheapest ways would be to build offshore wind turbines in Scotland and put a cable down the North Sea to get them the power. It would be far cheaper than doing it with the poor wind conditions you generally get in the north of Germany, compared with the 40% load factors in the North Sea. So quite an important message there. I was also going to pick up the marine renewables technologies, which for me is a little bit of a mixed bunch. Tidal stream is the first one I wanted to mention. Essentially, two-bladed wind turbines under the water, if you want to put it that way. That's essentially what they look like. There's a limited resource, but we have some of the best resources in Europe still. But it's potentially quite cost-effective, and a dominant technology design has now emerged. A company called Marine Current Turbines, which had put a trial thing in Strandford Lough in Northern Ireland. They've now been bought out by Siemens, which I think is a very good sign of confidence of an international major in this technology, and there's plans for rollout in Wales and Scotland. That contrasts a bit with my own personal views on wave energy, which I have to be cautious about because I have to be very neutral about this in producing my roadmap in about a year's time. There are very great hopes for wave energy in the UK, but perhaps some of it is based on it's just got to work kind of argument rather than looking at the underlying parts of it. The physical resource is huge in the UK, and it would allow us to transfer skills from the North Sea oil and gas sector in quite an important job creation way if it works. But this is one technology that I think was subject to huge technological exuberance and optimism in the last few years. There was a marine roadmap for 2020 which foresaw 2,000 megawatts of wave devices by 2020, and this quite simply was just fantasy, given that no dominant design has yet emerged for wave devices, and it's usually you need a dominant design to emerge before technologies really begin to take off. There's some very difficult issues still to exist because of the very hostile physical environment in which wave devices would need to operate, and the question of basic survivability of the devices is almost a question. So I'm not going to prejudge it, but wave energy is one I'm much more nervous about than some of the other technologies which I think are extremely promising. Now, one I want to stop a bit on is the question of bioenergy, and I think some of the issues I'm going to mention actually came up in the questions already. Bioenergy isn't a technology. It's an entirely new energy system that's almost parallel to fossil fuels if you're going to develop it, because there's many different feedstocks, there's many different processing chains, and there's many different uses, and it is an extremely complicated picture. Now, some aspects of bioenergy, especially bioenergy from waste, are pretty much no-brainers. If you've got landfill gas, if you've got municipal solid waste, sewage sludge, it's very obvious they're quite cheap options to pursue and put in place. It's when you start taking crops that were either originally intended for food or new kinds of crops that we get into very interesting issues. And I think the assertion I would make here is that there's actually quite a fundamental misalignment between what the science is telling us about bioenergy and the current policy position. In fact, the European Environmental Agency, its scientific advisors, pointed out this in rather strongly. The basic issue is that the current policy framework assumes that bioenergy is carbon neutral over the life cycle because you obviously emit carbon dioxide when you burn it, but you draw it in from the atmosphere when you draw the crops. Now this, in fact, is not true. It is not carbon neutral, and it does vary from one kind of processing chain to another. There is carbon emissions associated with processing, transport, land use change, and indirect land use change, if biocrops substitute for food crops, which are then somebody knocks down a virgin forest so they can grow food, we have indirect land use change that's extremely negative for the climate. We do at European level have some thresholds in the Fuel Quality and Renewables Directives that say which biofuels are good enough, but once they're good enough, you then account for them at zero emissions over the cycle. And this is particularly difficult for first generation biofuels, essentially for food crops. There are significant problems there. The other thing is that this was hinted at, I think, in the previous questions. At the moment, we all do our accounting on a territorial basis for our emissions. For example, fossil fuel producers take their responsibility for upstream emissions in the cycle, for mining, getting the oil out from under the ground that take place overseas. But for bioenergy, we reverse that position and we claim credit for the upstream sinks as you actually grow the crops in another country. And there is a fundamental illogic about the whole accounting system for bioenergy at the moment. Now that's not to say that we shouldn't be doing it, because it will reduce emissions with respect to fossil fuels, but I think the accounting framework needs to be much better adjusted to take that into account. And this also raises issues about what the appropriate use for bioenergy is. For a long time we were looking at biomass in dedicated power stations or to supplement coal firing. And the last report by the Committee on Climate Change on bioenergy really tended to be a little bit sceptical about that approach. The question is that we could be using so much bioenergy that has sustainability implications in terms of competition for food, the food versus fuel debate, and lack of sustainability of some of the cycles. So if the sustainable resource of bioenergy is lower than we think, we would be better reserving bioenergy use for those purposes where it has advantages and there are few alternatives to the use of bioenergy. And what the work of the Climate Change Committee found out, which is reflected in the government's bioenergy strategy just published, is that the outcome very much depends on whether we succeed in demonstrating carbon capture and storage or not. There are binary different futures depending on what happens. Because if we do have carbon capture and storage, by 2050 we could imagine burning biomass in power stations, capturing the carbon dioxide and then sequestering it under the ground, and the whole cycle will have effectively taken CO2 out of the atmosphere. We will have a CO2 sink rather than a CO2 source. Now that's quite visionary, but it depends on carbon capture and storage being developed. If, on the other hand, we don't get carbon capture and storage, it makes much more sense for bioenergy resources to be focused on difficult sectors like aviation or shipping, where there are few alternatives. And I can't think of any other area where there's a deeper uncertainty about the long-term direction in which the energy sector actually moves. And these long-term uncertainties have implications for the medium term, because we may lock ourselves into the wrong kind of infrastructure if we don't make the right choices for the longer term. Finally, I just wanted to say something on renewable heat. And I said right at the beginning that I think it's harder than electricity because there's lots of smaller players out there in the market who need to be convinced about the technologies. It's going to take a while to convince people that they'd rather have a heat pump in their house rather than a conventional gas-fired boiler. It's not an easy thing to do. And so for that reason, I think the government rightly is concentrating on the non-residential sector first, commercial buildings, small businesses, that's the way to go with renewable heat. But one thing that I think there is actually, the one point where I say I think there is potentially a deep incoherence in government policy at the moment, is that private consumers are going to be bombarded by a number of different initiatives. The Green Deal to support energy efficiency and the renewable heat incentive to try to move them towards heat pumps, biomass boilers. And the business model underlying the renewable heat incentive is completely different from the business model underlying the Green Deal. With a renewable heat incentive, you will have to pay up front, you put your equipment in, and then you will actually be paid a feed-in tariff for the renewable, effectively for the heat that you produce. With a Green Deal, you'll be able to borrow all your upfront money, and then you effectively pay what is a loan but is not a loan back over the lifetime of the equipment. And so we have two different models where you might have the same people coming in to approach you and making two different kind of propositions, which is quite confusing. And again, one of the strong recommendations of the Committee on Climate Change has been to reconcile these very different approaches for renewable heat and efficiency. So I'm going to just finish off at this point with my general points about policy orientation and risks. And this is where I just have to underline how important the electricity market reform is at the moment that the government is pushing through. Renewable energy and nuclear energy have very high capital costs up front, but have very low running costs. And our current electricity market simply does not support that kind of investment profile. And so the electricity market reform is designed, as David has said, to reduce this market risk. And I think I completely agree with the point on nuclear. Nuclear's problem is both market risk and technology construction risk. And EMR has addressed one half of the problem, but has not addressed the other half for nuclear. So I put it slightly, I think they've cured half the problem, but I don't think they've certainly gone the whole way. Now, the other thing is that the statement, ministers have said that they want the three main technology groups, renewables, nuclear, and fossil fuels with carbon capture and storage, to compete against each other in the 2020s without government was coming in and picking winners. I think this is going to be a very different kind of thing to do because the costs and risks associated with each of these technologies is very different. Because, for example, fossil fuels with carbon capture and storage is still exposed to fluctuations and volatility in fossil fuel prices, which means they would need a different kind of feed-in tariff, I think, to carry through than you would need for nuclear and renewable energy. Equally, renewable energy, because of its intermittency, its unpredictability, if you're doing this through the fabled contracts through difference, it needs a very short-term reference price, otherwise wind would find itself disadvantaged with respect to nuclear. So even if government doesn't want to pick winners, it's going to have to set the rules by which the winners pick themselves. And this is where it's actually going to be quite tricky to get this electricity market reform to work effectively. And just to echo everything I think that David has said, renewables are potentially the least risky of all of these options for investors at the moment. I was at a meeting in Germany where there was a member of the E.ON main board the very day that they made the decision to pull out of the nuclear consortium in the UK. And there was a very clear message that the 10 years it takes from when the point you start putting money into nuclear for when the money starts to flow back again, plus the poor record of construction, building to time and cost in the nuclear industry, is the factor that makes them nervous. With an offshore wind turbine, you know you can build it to time and cost, and you know your money is going to start to flow back again within 2 or 3 years. And in the current climate, that is much more attractive for businesses who have to make difficult decisions. So I think CCS also not demonstrated yet. So I think as long as the government support is in place, renewables is what the companies are going to prefer broadly. Now, in terms of risk, the kind of risks and how government can go about overcoming them, I mentioned one of the risks is the defeat of so-called wind power Toryism and climate scepticism. There is a major political risk now, I think, around the climate agenda. We have a very different parliament from the parliament that passed the Climate Change Act back in 2008. I think the concerns about the impact of renewable support on electricity bills is another risk that needs to be managed. By investing in renewables, we will bring the costs down eventually. It's the question about whether any short-term additions to bills, which are mostly greatly exaggerated, undermine the longer-term prospects for the technology. And the other one I think that I do feel nervous about is, are the British public up to it in terms of adopting more ambitious energy efficiency measures and renewable heat? So what I think the government needs to do, it needs to keep the pace up on electricity market reform. And I have to say, like many of us actually were astounded by the ambition of the original electricity market reform package when it came out. We thought, they're really up for this one. So Robin, that's why I think we have come a bit of a distance actually. It was a really ambitious package. Government needs to put in stable long-term signals. It shouldn't do what the Spanish government has done and completely repudiate contracts and feed-in tariffs, because that is truly damaging to investor confidence. And finally, they need to continue to sell it to the public, which broadly is still on board in this agenda with all the social science work that we've been carrying out. So I think my conclusion, to go back to the title of my talk, I do think HMG actually gets it. The question for me is, do they have the political will? Have they got what it takes to carry it through? That's the actual big question for me, and I'll finish there. Thank you.
Thank you very much indeed. I don't know whether other people think so, but I've been feeling increasingly optimistic, which was not what I was expecting for today. Yes, Roy.
Well, I saw in the discussion, I've seen it many times. How come geothermal is never considered to any of these equations?
Partly because I think in comparison with many other countries, I was in New Zealand in March. I know Italian colleagues who work on geothermal, and in comparison, it's not as big an opportunity in the UK as it is in some other countries. There is an incredible debate about whether ground source heat pumps should be classified as geothermal or not, how you actually classify them.
That's not true. Various evaluations shown that UK has the potential of supplying 10, and now the SKN report just coming out, and the REA saying 15, and I suspect up to 20% of the UK energy. But there's been a very, very slow government support, and unless government can do something about it, we will find countries like Korea and others are taking it up. Germany is taking it up, which is the worst condition in Europe for geothermal. They're forging ahead. France has increased its feed-in tariff to comparable with Germany, so has Spain and others. How come we are lagging behind in this support?
Don't know. Give me your card and I'll take it into account when I'm working on the roadmap, which is my next job.
Well, I don't like inviting distinguished speakers that together, but when you say there's room for optimism, passing legislation costs nothing. The only thing that matters is the amount of CO2 in the atmosphere. That's the only thing that ecosystems in the world understand. And since 1990, the baseline year for Kyoto, annual emissions of carbon dioxide have gone up 49%. And in the UK, they've gone up 23% if you take account of the fact we've exported our carbon footprint. So, one way of trying to solve this problem is to get people to insulate houses and things of that nature. That would make a huge difference. Have you considered the proposal I put in the Times last week, which was to price energy use and make it increasingly expensive the more you use? Because that will protect the poorer households, like you can subsidise them. Then heavy users of energy get heavily penalised, and if you're profligate, you get really heavily penalised. That would give people a very powerful incentive to reduce their carbon footprint.
Yeah, I mean, a number of points in there. When the CCC was looking at fuel poverty issues and went into it, we did look at the possibility of these rising step tariffs as an option, for actually doing things. And the trouble with the fuel poverty and the cost issue is that people are very varied. It's a very niche kind of market, and no matter how you could design something, you were always hitting somebody poor, because there's somebody sitting in a huge house that's badly insulated with a poor system. It is very difficult to design a system like that unless you've really gone in and worked on the insulation side as well. I completely agree with the idea that we could tax energy much more than we do. I've heard many UK people complaining about the fact that electricity is subsidised in the Middle East, ignoring the fact that we only have 5% VAT on domestic oil and gas and electricity is actually a 15 to 20% subsidy if you look at it overall. And the fact that we do not in any way tax gas, I think, is one of the biggest problems. It's actually favoured within the fiscal environment we have at the moment, whereas other forms of energy are hit much harder.
Well, you may have to risk hitting your household. It's better than hitting the whole planet, isn't it?
I think this mechanism was used somewhere else, that the existing electricity supplier should be obligated to supply a certain percentage of their power from renewable.
Well, I mean, in a sense, we do have that with a renewables obligation, except, of course, that they have a buyout price that enables them to get out of it, which means that we have about a 70% achievement of the renewables obligations targets. I mean, there's been an endless debate around Europe as to whether obligations or certificate systems are better than feed-in tariffs for promoting renewable energy. And the consensus, I mean, it's not clear-cut, but the consensus is broadly that feed-in tariffs do a better job than renewables obligations because they produce a more consistent price that gives certainty to investors. Whereas with an obligation, the certificates are tradable, you get volatility in the market, and it works to the advantage of bigger players and keeps smaller people out, new entrants out of it. So that is one reason why we've made this heroic jump in the UK to move away from a renewables obligation to a system of feed-in tariffs.